We're still in 11.8 on power series. And at the end of class last time, we summed up what we learned from our examples that we did. So I want to do that again for a given power series. So the formula again is n equals 0 to infinity, Cn x minus a to the n. There are three possibilities. So the first possibility is that your series only converges when x equals a. The second one we saw last time was that your series converges for all values of x. And then the third was that it converged in an interval. The series converges in an interval. So those are the three possibilities we saw last time. Series only converges for one value, it converges for all values, or there's an interval where it converges. Let me formalize this interval part. I.e., there is a positive number r, such that the series converges if the absolute value of x minus a is less than r, and diverges if it's bigger than r. X minus a is bigger than r. Okay, so those are my three possibilities. This number r is special, it's capital R, and we're going to call it the radius of convergence. So I'm going to define that for you. The number r in 3 is called the radius of convergence. Of the power series. So really it's just, this r corresponds to an interval, it's just the radius of that interval. Well, if I look back at my other possibilities, they don't have this value r. The series converges for only one value, or it converges for all values. So in these cases, we're still going to have a radius of convergence, but I have to tell you what it is. So for 1, my series only converges for one value, so we're going to say its radius of convergence is 0. The radius of convergence is r equals 0. That's just because you have a single value, and so if I'm thinking about it on a number line, it's just a single point, so there's no radius.
Oh, where it's centered in 0.
where it's centered at A,
At A.
at whatever your converging value is. So I'll draw a picture in just a second. For 2, well, it converges for all values, so by interval, we wrote it out last time, it was negative infinity to infinity. So we're going to say that the radius is infinity. The radius of convergence, which eventually I'm going to start abbreviating as ROC, is infinity. Yeah.
Do we have to write out radius of convergence?
You can write ROC, that's fine. Just like I abbreviated for the tests, like AST, you can do that. Okay, so what's going on, just so you get a picture, is if you had converging in an interval, so like the one we did last time, my interval was 2 to 4, the center of that was my A value, which is 3, and I'm looking in between here. So to get the radius, it's how high up from the center you gotta go, or how low from the center. How high did I have to go? I have to go up 1, right? Down 1. So for this one, our radius of convergence was 1. This was our example from last time. Okay. If it converges for just a single value, then you don't really have an interval anymore. It's just a single point. And so that's why you're saying the radius of convergence is 0 here, as it's just a single point, there's no radius. And then if you have negative infinity to infinity on your number line, it's the entire thing. So you can think of that as being centered at A. Nope. Centered at A. And so this is why we're saying the radius of convergence is infinity. Okay. I also wrote here an interval, right? We did that a lot last time. I wrote down the interval where all values where my series converged. And so we're going to call that interval the interval's convergence. Which I will probably abbreviate as IOC. Is all values of X for which the series converges. So we've learned 2 new terms, radius of convergence and interval of convergence. So I thought we'd take all of our examples that we did last time, and I would write down what we found out last time and write down the radius and interval here. So from the previous examples, we have, so let me make a table here where I write down, I'm going to write down 4 things. Series, where we said it converges, radius of convergence, interval of convergence. So the first series we looked at last time was x to the n, We said that converges if x is between -1 and 1. What's our radius of convergence here? 1. The center of my interval is 0, so I go up 1 and down 1. So that's my radius of convergence. My interval of convergence, -1 to 1. All right, and then we did this series, I think was our next example, n factorial x to the n. If you look back in the notes, we said that this only converged for one value, x equals 0, x equals a. What do we say the radius of convergence is when there's only one value? 0. And then here, because it's one value, your interval of convergence is not really an interval, it's just the single value 0. So I use curly braces, which I can clean up for you so it looks a little bit nicer. It's just that single value. Okay, and then we saw this example. This was the next one we did last time. X minus 3 to the n over n. We said it converged when x was between 2 and 4, including 2. So I mentioned this one earlier. I drew the picture. Our radius of convergence was also 1. And I write that as an interval. What would my interval be? Two to 4. Bracket, parentheses, yep. And then the very last one I think we finished at the end was x to the n over n factorial. We said it converged for all x. My radius of convergence, infinity. And then my interval, we wrote that down last time, -infinity to infinity. Okay? So we kind of already talked about at least interval of convergence last time. We didn't really talk about radius of convergence, but it was secretly hidden in our answers.